Hi, welcome back to My Smart Learning. This is a lesson for, in particular, it's year 10s. However, this is useful for year 9s as well. This lesson about power, you need it for year 9s and you also need it for year 10s. In year 10, however, you do it for the electrical circuits part of the topic, but it also comes up in the energy topic in the physics textbook in chapter 1. So it comes up in chapter 1 in physics, but it also comes up in chapter 4, and chapter 5 in the physics textbook. Now, some people get confused between which, if they're doing trilogy or if they're doing separate. The stuff that I'm doing on these videos is for all of them. So trilogy students need to know it, as well as separate students need to know it. So it's useful for you guys to watch these videos and just to brush up on your science lessons. It's also useful for year 7, so if you're year 7 watching it, because I'll post some of these videos on the year 7s, show my homework, also the year 9 homework and the year 10 homework. Some of the stuff overlaps, so it's stuff that you all need to know. Now, the minimum you need to do though is watch these videos, because I do go through things quite thoroughly. The extra bits are what you need to do is if there's any questions on the PowerPoints, or if there's textbook pages in the Caboodle, you can use those too. What I'm focusing on today then is power and fuses. So half of this is year 9 work, and then about halfway through this lesson I will sort of stop the year 9s, you can stop at that point, and then I'm going to go on to more about fuses and electrical power. I'm going to come on to this idea about power in a second. So for year 10s in particular though, you're looking at electrical power and how you can calculate the power rating, or work out the power rating of an electrical appliance and work out how much current is going through that appliance, so you can work out which fuse to use. Because the last thing we looked at last week was the 3-pin plug, and in the 3-pin plug you've got the different wires and you've got the fuse in there. But today we're going to look at in particular how do you work out which fuse to use, and that rhymed if you didn't get it. So anyhow, recall quiz then, a recall PT, high five, get all 5 right, you get a virtual high five from me. So for year 9s, I'm not expecting you to know these, but for the year 10s, what colour is the live wire? Question 2, what colour is the neutral wire? Question 3, what colour is the earth wire? Question 4, can you draw the symbol for a fuse? And question 5, what is the purpose of a fuse? So that's stuff we did for year 10s last week when we looked at the 3-pin plug. If you pause the video, quickly have a go at the answers, and then if you've unpaused it now, we'll quickly go through those. So the live wire is brown. So when you look at the cables, the live wire is brown. The neutral wire is blue. The earth wire is green and yellow, because there's 2 colours in there, green and yellow. The symbol for a fuse is just a rectangle that you have for a normal resistor, but there's a line that goes straight through it. So it's just a rectangle with a line that goes straight through the middle and across the other side. So that's the symbol for a fuse. And what is the purpose of a fuse? It's a safety device. If too much current flows through that circuit, it melts the fuse, it breaks the circuit, it prevents the appliance catching fire, and it stops you from getting electrocuted. So that's that. We did this last time, looked at whether it's true or false about the plug, and we also looked at this is how a 3-pin plug is wired up correctly, and then we also went through the things that were wrong about the wiring of the plug. If you missed that, you can go back to the previous lesson and you can watch that through. It's also on the PowerPoint, so you'll be able to use that there. Now, what is power and what is the relationship between energy? So the power rating, I've got the power, right? So the power rating is the amount of energy something uses per second. So the amount of energy used per second, that's the power. So if you say something's got more power, it's either using up more energy more quickly. So that's the definition, so you might want to write that down. In other words, remember the unit for energy is a joule. The unit for time, the amount of time, is in seconds. So 1 joule per second is 1 watt. So the unit of power is a joule per second, which is also known as a watt. So watt is the unit of power, That was a statement, not a question. What? What is the unit of power? So watts. Now the triangle formula then, this is the thing that you guys need to memorize, because most of the physics formula you don't get given to you in the exam. You need to memorize those, so you need to commit to memory. It's quite useful to memorize it as a triangle, because you're more likely to be able to rearrange it more quickly. So E stands for energy, and that's in joules. The P is the power in watts. The T is the time in seconds. Now, if you don't know how to use one of these triangles, if I'm trying to calculate the power, I put my hands over the P there, and you've got the energy divided by the time, because E over T. So it's the joules per second. If I wanted to work out the energy though, I'd cover up the E, and what I've got left is P and T, and because they're next to each other, it's power times time. So energy equals power times time, and power equals energy divided by time. If for some reason you wanted to work out the time, you'd have to cover that up. It's the energy divided by the power, and then you have to make sure you always use seconds. So can you make sure you write those down into your notes, and you need to memorize that formula. Okay, so power is energy divided by time, or energy is power times time. Right, let's move on then. Some questions. What is the power of a toaster that uses 45,000 joules of energy in 100 seconds? So the power rating, remember, the power rating is the amount of joules per second. So you need to know it for 1 second. So if I've got 100 seconds, I need to divide that number by 100. So it's the energy divided by the time. So which answer would it be? You've got a choice of the green, the blue, the red and the yellow. Now obviously this is interactive. Please don't go around pointing at your, touching the screen and thinking, why doesn't that work? Or, it's just the colours on the screen. So you got that divided by that. It's literally take off 2 zeros, you get 450. But 450 what? That's right, 450 watts. Because the unit of power is watts, not joules. It's joules per second or watts. So the red is the correct answer, 450 watts. So that's an example question. Now we're going to look at some exam questions. It's on this slide. I've also put it on your Show My Homework. I've uploaded it, so you got the PowerPoint on Show My Homework. Have a go, pause the video, have a go at them on some lined piece of paper or in your exercise book. And then what I'll do is after I've unpaused it, or you've unpaused it, we're going to go through the answers for these. So either freeze the screen and have a go at these questions, or use the PowerPoint I've uploaded on Show My Homework for my students in year 10 and 9. So it's for year 9 and year 10. So if you can see those questions, right, so I'm going to go through the first 3. If you've got unpaused it, right, so the answers then. So the power rating of a light bulb, you got 120 in 2 seconds. So the power rating of a light bulb that transfers 120 joules in 2 seconds, well, power is energy divided by time, so it's 120 divided by 2, which gives you 60. So it's 60 watts. What's the power rating of the Xbox 360? It shows you how old this PowerPoint is, because obviously there's Xbox One and Xbox One X and X1 and Xbox Series X and Xbox Series XX. I'm not going to do another X, that's triple. Right, so how are you going to work at this one? The power rating of the Xbox 360 is 10,000 joules divided by 5 seconds, so it's the energy divided by the time. So it's 10,000 divided by 5, which gives you 2,000 joules per second, or 2,000 watts. Now you can put prefixes in front of that. So 2,000 is the same as 2 kilowatts. Okay, so that'll be 2 kW. Farhan runs up the stairs in 4 seconds. If he transfers 1,000 joules of energy in this time, what is his power rating? So again, power is the energy divided by the time. So it's going to be 1,000 divided by 4, which will give you 250 watts. Okay, 250 joules per second. Here's a quick little extension question that wasn't on the previous slide. I'll go through the previous slide in a second. What uses most power? Is it a kettle that uses 200,000 joules of energy in 100 seconds, which is a little over 3 minutes, or a washing machine that uses 500,000 joules in 5,000 seconds, and explain why? So again, the power rating will be this divided by this. So you'd have to go 200,000 divided by 100, you take off those 2 zeros, you get 2,000 watts, and your washing machine will be 500,000 divided by 5,000, so you'll be 5 divided by 5, which is the 1, take off 3 zeros, so you're going to get 100. So the kettle's going to be 2,000, and the washing machine is going to be 100 watts. So the most power hungry is the kettle, because kettles get extremely hot. And the last 3 questions, I haven't got the answers on the screen, so I'm just going to do them here. How much energy does a 150 watt light bulb transfer in 1 second? So if it's 150 watts, remember 1 watt is 1 joule per second. So in 1 second, that one, question 4a, will be 150 joules in 1 second. So what about in 1 minute? So I'll get my calculator out. You need a calculator for this lesson. Please have your calculators ready. If you haven't, press pause, run off quickly and grab your calculator, because these calculations will be a bit more trickier. So if you unpause and come back, well done. So 1 minute then, so 150 in 1 second. So do 150 times 6, now you could do it in your head, that comes to 900 joules of energy in 1 minute, because that's 60 seconds. Remember, energy is P times T, so it's the power times the time, but the time has to be in seconds. You can't leave it in minutes. What about Sean's brain? Sean's brain needs energy supplied to it at a rate of 40 watts. How much energy does it need in a physics lesson? Now, a typical physics lesson is 1 hour. So first turn your time into seconds. So 1 hour is how many minutes? So it's 60 minutes in 1 hour, times it by 60 seconds for every minute. So that's going to be times it by 60, 3,600. Okay, so 3,600 seconds in 1 hour. Now, how much energy has he transferred? Remember, energy transferred is power times time. So the power is 40. The time was 3,600. So I'm going to times it by 40. And that gives me an answer of 144,000 joules of energy. So 144,000 joules. And if you want to write that in with the prefix, you'd say 144 kilojoules. Okay, 144 kilojoules. Damien's brain, being more intelligent, only needs energy at a rate of 20 watts, so it's using less power. How much energy would his brain use in a normal day? Now, if we're talking about a normal day, let's just say a 24-hour day rather than a school day. Is it talking about school? Because it doesn't really say in this question. So if it's just saying a normal day is 24 hours. So 24 hours is in a normal day, that's 24 hours. And how many minutes are there going to be then? So you times it by 60, because 60 minutes for every hour. So I'm going to times that by 60, which equals 1,440. And then I'm going to times that, because that's how many minutes I've got. I need to times that by 60 again to give me my seconds, which is 86,400. So 86400. That's how many seconds you have in 1 day. And his power rating is 20 watts. So I'm going to times that by 20. Because remember, energy is power times time, times it by 20, and that gives my final answer of 1728000. So that's 1,728,000. So 1,728,000. You could write it with a prefix 1.728 megajoules, MJ, not Michael Jackson's. MJ stands for megajoules. So that's the answer to that one. Now, that is pretty much what the year 9s and 7s need to know. So year 7s and year 9s, you can stop the video there, because that lesson on power, on what is power, is the amount of energy you use per second. So the power is energy divided by time. So you need to memorize that formula and then be able to apply it to some questions. So for year 9s, that's the end of your lesson. For year 7s as well, year 7s and 9s, that's the end of your lesson there. So you can stop the video there, but obviously click the like button and share and subscribe if you haven't. Year 10s, you need to carry on, because we're looking at electrical circuits and how we apply power to working out which fuse to use. Which fuse should I use? Right. You like the poetry? Yes, very good. Now, power is the rate of doing work. The amount of power being used in an electrical circuit is given by, like we said, this is a different formula, right? There's 3 formulae that you need to memorize for power in physics, okay? So in year 9, you just learned the first one, which was power equals energy divided by time. Now you're going to get 2 more. So it's going to be 3 in total. So the power is the voltage times the current. P equals V times I, or I like to call it I times V. It doesn't make any difference because they're the same there. That times that. So the way I remembered it was PIV. P over P equals IV. The other one, I remember it as PET because it goes PET. So power equals energy over time. This one I remember it as PIV. PIV, or you can do the I and the V the other way around, doesn't matter. So PIV, again the power, you put your hands over that. Power is the voltage times the current. The current is the power divided by the voltage, and the voltage is the power divided by the current, and you cover it up like that. Okay, so here's a little quick question for you to have a go at. Can you make sure you write that down into your notes, and you need to memorize that like all the other physics formulae. If you press pause on the video, have a go at answering this question. I'm going to go through it in after you've unpaused it. Okay, so if you've had a go, using this equation, we can work out the fuse rating for any appliance. For example, a 2 kilowatt, which is a 2000 watt fire, plugged into a 230 volt supply, would need a current of something. Well, what's the current going to be? You put your hand over the Pi, it's going to be P divided by V. So the P is that, which is 2000. You can't write 2 because 2 kilowatts is 2000 watts. You need to make sure it's in watts. So 2000 divided by the voltage, which is 230. So divided by 230 equals 8.695, and this goes on forever. So if I round it to 1 decimal, I could round it to 1 decimal place because it'll become 8.7. So it's 8.70 or 8.7. So it's 8.7 amps. So a something amp fuse will be used. Fuse values are usually, now here it's giving you a 3, 5 and 13. So which fuse would I use? I would use, now my current flowing through is 8.7. So I can't use a 3 amp fuse because a 3 amp fuse would melt. Because a 3 amp fuse, as soon as it hits 3 amps, the current's too much, the wire gets hot, it's softened, and it melts and it breaks. If I use a 5 amp, the same thing would happen because 8 amps is, of current is flowing through. Whereas a 13 amp fuse can handle 8.7 amps, so it won't melt. Okay, so in this situation, I would use a 13 amp fuse. So that's how we work these out. Lots of different appliances. So in the practical, if you were doing this in school, you'd have a practical where we'd get the voltage and the current of different appliances, and we can work out the power rating. Or you can get the appliance and look on the back, and you'll notice the power rating. So for instance, you're gonna have got this at the moment. If you pause the video, you can draw this out, or you've got the PowerPoint I've sent and shown my homework. You can try to fill in these numbers on the PowerPoint. Okay, and I'll go through the answers in a second after you've had a go at filling in the table. How does it work? Right, so every appliance has a power rating. So you can see all of these different appliances have a power rating. Everything you use that uses electricity has a power rating. So here's my laptop. I've got my little transformer here. Okay, and on here it will tell me that the input is 1.5 amps, it's got 240 volts here, but the mains is 230 volts, and it's giving me the output. Okay, here we go. So I've got an output of 19 volts from this, and the power rating on this, it hasn't given me, so I can actually work out the power of this. 0.202. Right, so I can work out the power of this particular appliance because it hasn't given me the power rating. Usually the appliance you look at, if you're on the stickers on the bottom, it'll tell you the actual power rating. Now with this one, my output is 19 volts. So remember, P equals IV, so my V is 19, so I've got 19, times it by my current that's flowing out of this, which is 4.74, 4.74, so my power rating for this is 90 watts. So I get 90 watts. So it's 90, my laptop is running off 90 watts of power. Okay, so which fuse would I use? Now I've got 4.74 here, so that means I can use a 5 amp fuse in my plug here. Should be a 5 amp fuse. You always use a fuse that is slightly higher than the actual current. If you use one that is bang on the number, what will happen is that every time you plug in and switch it on, it'll just pop, it'll just melt and blow and it won't work. You always use a fuse that is only very slightly higher than the actual current running through that appliance. You never use it below. If it's too low, it will just melt straight away as soon as you put it in. If you put it on bang on, again, if you just get, because current doesn't come as a continuous flat line. It sometimes goes a little bit above, sometimes goes a little bit below, but it maintains roughly about where you want it to be. So you want a fuse that is slightly higher. Now there are other fuses. Now here it's giving you 3, 5 and 13. There are other fuses. You can get a 1 amp fuse. You can get a 10 amp fuse. Okay, these are the sort of the standard ones. So technically I could use a 5 amp fuse for my laptop, but that's too close because I got 4.74 current. So if I put a 5 amp fuse in there, if I just get a slight spike, it'll blow that 5 amp fuse. So I'd probably want to use a 10 amp fuse instead. Or if I can get 7 amp, I'll get 7 amp. That would be actually more useful. Now, if you've had a go at this then, you need to work out the current. So that's how you work out what fuse to use. Now, if I've got the power rating here and I got my voltage there, I can work out which fuse to use. So the current, remember, P equals IV, so I is P divided by V. So each of these numbers you need to divide. So for the first one, it's 960 divided by 230 equals 4.17. So that's a little over 4, so 4.2 amps. So you could use a 5 amp fuse. Okay, so it's roughly working at 4 amps. 5 amp fuse for the toaster is fine. This one then, it will be 2000 divided by 230 equals 8.7 again. So it's 8.7 amps. So I'm going to have to use a 13 amp fuse. I'll have to use a 13 amp fuse because 8.7, the next one up is 13 amps. The hairdryer then will be 300 divided by 230 equals 1.3. So this answer is 1.3 here. So I'd use the 3 amp fuse. The Hoover is 1000 divided by 230 equals 4.35 around it, 4.35. So again, I'd probably use the 5 amp fuse because it's just slightly above the rating I need. So that's for my Hoover. My computer, you can tell straight away 100 divided by 200 divided by 230 is going to be less than half, 0.43. So that's 0.43 amps. So I'm going to use a 3 amp fuse. And the last one, again, that's going to be really small, 80 divided by 230 equals 0.35. Again, that's less than 1. So I'm going to use a 3 amp fuse. So far we've learnt that there are 2 equations so far that we've done. Power is energy divided by time, and power is current times voltage. And using that formula, we can work out the current, and then we can work out which fuse to use for your appliance. If you go around your house and have a look at some of the appliances, just lift them up, look underneath, there'll be a sticker there. Usually it'll tell you the voltage. Now the voltage for the mains, most of your appliances is 230 volts. And it'll tell you the wattage, the power rating. So you do the power divided by the voltage, that will give you the current, and then you can work out which fuse to use. Last thing then, another power equation that you need to learn. Power is also I squared R. I squared R. So what does that mean? I squared R is the current times the resistance. So I squared R, P equals I squared R. That's another one you have to memorize. Again, you can put this into a little formula triangle because you can put the P at the top, I squared there, and R there, the resistance. So if you want to work out the resistance, you cover up the resistance, it will be power divided by current squared. If you wanted to work out the current, it would be a little bit more trickier because you'd have to go cover up the I squared, you do the power divided by the resistance, but then the opposite of I squared will be square root. You'd have to square root the power over the resistance. Gets a little bit more trickier. Now you're not going to expect to do that, you're just going to be expected to be able to calculate the power by sticking it into that, like a substitution question. So pause the video, have a quick go at these questions. These are really straightforward, simple ones. And then once you've had a go, you can unpause and we'll have a go at that. So I equals 2, So then that will be 2 times 2, because 2 squared is 4. 4 times 10 is going to be 40. So the answer to question 1 is 40 watts. Question 2 is going to be 4 times 4, which is 16. 16 times 100, which will be 16 with 2 zeros, will be 1,600 watts, or 1.6 kilowatts. This one then, 2 times 2, because the current's 2. 2 times 2 is 4. 4 times 5, 20. So question 3 will be 20 watts. And then question 4, 0.5 times 0.5. Now this is one that tricks people. People get confused with this one. 0.5 times 0.5. If you half times a half, you actually get a quarter. Now if you don't believe me, I'll stick it to the calculator and show you. You get 1 quarter, if you could see that. So 0.25. So 0.25 times 20. So if you times something by a quarter, you get a quarter. So times 20, you get a quarter of 20. So you'll get 5. So that is 5 watts of power. And the last one here, 2 times 2. 2 times 2 is 4. 4 times a half. If you times something by a half, you half it. So 4 times 0.5 will give you 2. So the question 5 is 2 watts. So 3 formulae for power. You got power equals energy divided by time. You got power is current times voltage, P equals IV. And you've got power equals I squared R. You need to memorize those 3 formulae. And how confident are you? So, have you learned those? Have you memorized those? If you're feeling confident, I'll have a go at the green question on the next screen. If you're feeling okay, have a go at the blue question on the next screen. If you're not very confident, then have a go at the red question. So, here is the questions. Have a go at those. Okay, so if you're confident, you're going for the green. If you're okay, you're going for the blue. If you're not so sure, you're going for the red. So green is go, go, go. Blue is okay. Red is stop. And let's go back to the basics. So just do the question that you think you're on. And then I'm going to go through all the answers for all of these anyway. So if you unpaused it after you've had a pause and had a go at it. What is the equation for power? Well, there's different ones. So you've got P equals IV. You've got P equals E over T, energy divided by time. And you've also got P equals I squared R. What 2 things does it rely on? Well, it relies on energy and it relies on time, and also relies on current and it relies on voltage. Why do different appliances, e.g. toaster / phone, have different power ratings? It's to do with the amount of energy they use per second. Okay, and different appliances get hot by different amounts. In 10 seconds, so the blue question then, in 10 seconds, one light bulb uses 500 joules of energy, whereas another uses 200 joules of energy in 1 second. Calculate the power for each one. Which bulb has the greater power and why? Well, it says in 10 seconds, so you need to divide each of those by 10. So 500 divided by 10, that'll give you 50 joules per second, which is 50 watts. And that's going to give you 200 divided by 10, which will give you 20 watts. So the first bulb is a 50 watt bulb, it will be much brighter. That one is a 20 watt bulb, which will be just under half the brightness of the first one. So the 50 watt bulb is brighter, or has a greater power, because it's using 500 joules in 10 seconds, so it's 50 joules in 1 second, more joules per second. Okay, the go, 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 green question, if you're confident. 2 cyclists both use 50,000 joules of energy in a race. One finishes in 100 seconds, the other in 200 seconds. Calculate the power for each one. Which cyclist has the greater power and why? So again, you just need to divide that one by 100. So power is energy divided by time. So it's 50,000 divided by 100. So just take off the 2 zeros. This first guy uses 500 watts of power. And the next chap is using a lot less power, because he's going to be, divide that by 100, which will give you 500 divided by 2. So it's going to be 250 watts. So you should see 500 watts, and then this guy is doing it in twice the time, so he's using the energy, he's taking twice the amount of time to do the energy, so he's getting half the power rating. So 50,000 divided by 250 will give you, so 50,000 divided by 200 will give you 250. So we've got 500 watts for the first cyclist and 250 watts for the second cyclist. So the first cyclist has the greater power because he's using energy much faster. It's the same amount of energy, but it's using it much faster. Okay, so if you want to do extra work, there are extra questions on the PowerPoint from your Caboodle exam style questions. If you've got time, you can have a go at those questions there. Okay, and there's some key points you can get down in your notes. If you've understood what power is and you've memorized your 3 formulae, that is fantastic. If you're year 9s or 7s and you stayed right to the end of the video, even better. So I'm glad that you're learning even more stuff for stuff that's going to come up in the future in your year 10 work and in your GCSEs. It's all very important. If you've learned something today, please like the videos, share the videos, watch the physics videos obviously, and if you haven't already done so, please subscribe or get other people to subscribe. If you're learning stuff and it's been useful for you, I appreciate you watching these, and I hope it's been helping. Please stay safe, and I'll see you guys back at school. Take care, and a massive virtual high five from me.